Hello and good afternoon, CSI257 Section 847 students for the first 8-week term of the Spring 2015 semester at Anne Arundel Community College. This evening's video tutorial is going to be on PacketTracer Activity 7.4.3.4, where we're going to go ahead and delve in and take a look at EIGRP for IPv6. So we have our address table here with all of our global and link local IPv6 addresses. And this activity is actually going to walk us through the steps, which is good. It kind of eases us into the IPv6 portion of the configuration when using EIGRP. So let's go ahead and pull up each router here right away. So we've got router 1. And we're going to pull up router 2. As well as router 3. Alright, so we'll simply start on router 3. It just basically asks us, because by default IPv6 is not enabled on the Cisco iOS. So what we want to make sure that we do is we want to go ahead and configure the router so that it will use so that it's capable of using IPv6. So we're going to say enable to go from user exec into privilege exec, and then we're going to issue the configure terminal command to go into global config. And it's simply from global config where we say IPv6, and a little too many ends there, unicast routing. And so that enables it on router 3. Let's come over to router 1, where we'll say enable config T to get into global config, and then IPv6 unicast routing. And then we're going to do the same thing on router 2. So we'll go from user exec to privilege exec, and then into global config and IPv6 unicast routing. All right, so now that we've got IPv6 routing enabled on each of the routers, we are going to go ahead. It says enable EIGRP for IPv6 routing on each router. And so it says the IPv6 routing process is shut down by default. So issue a command that will enable EIGRP for IPv6 routing on routers 1, 2, and 3. So when we enable the EIGRP process on all routers, we're going to use autonomous system number 1. So let's go ahead and do that configuration. We'll simply start here with we'll simply start here with router 2. So I would say IPv6 router EIGRP, and we're going to use autonomous system number 1. So if I do a do show run right now, and it's going to bring us down here to the EIGRP section, you can see that by default it has us shut down. If I do a do show version, and this is interesting here, so this is 15.1 code, right? 15.1 code. And typically what you'll find with the 15 code is that it is not shut down by default. Let me pull up here. Here we go. So these are some of the routers I was working with the other night. These are just simply Cisco 1841s. And if I were to say show run, and it's easier here with the real iOS, I can say section EIGRP. You can see that there is no shutdown command here, and by default there was no shutdown command. So literally if I was to say no IPv6, no IPv6 router EIGRP1, right? Let me go ahead and I'm just going to recreate it again. So I'll say IPv6 router EIGRP1. So if I say do show run section EIGRP, you see right here where it is not shut down. And this is 15.3 code over here. And so typically in 15 code, I was actually on some 2901s today, and they were running 15.2 code. And same thing with the 15.2 code, it is not shut down by default, but you definitely want to check to make sure that after you enter the IPv6 EIGRP router config area, you want to do a double check to make sure the process is not shut down. And if you're anticipating that an adjacency is going to form, then by all means, definitely check. And let me cut and paste this back in here. All right. And so I've just basically put back the configuration the way it was to show that by default with the 15.3 code that I'm running here, it's not shut down. So this shows 15.1 code, but again, it's PacketTracer, so I can't actually do the pipe to the section command, but you can see here it says shut down. So what do we need to do? We need to simply say no shut, right? Okay. So that is going to be step number 2, and we're going to do that on all 3 routers. So let's come over here to router 1. I'm going to say IPv6 router EIGRP, and it's going to be autonomous system 1. And again, key to remember here is the number that follows EIGRP in that command, that IPv6 router EIGRP command. That is the autonomous system number. It is not a process ID. And so what I mean by that is with OSPF, we use the process ID, which was locally significant. This value here that we're placing after EIGRP, that is the autonomous system, or it's referred to as the AS, and that is a globally significant value. So in order for our adjacencies to form with our EIGRP neighbors, the AS numbers need to match. If they don't match, the adjacency will not form. And if you remember back to OSPF, it was just the opposite, where the process ID, when we would say router OSPF 1 or 2 or 3, those were locally significant values where it didn't matter if they matched or not. The adjacency would still form. It had other values that it was dependent on, such as the hello interval, the dead interval, and the timers. So let's go ahead and continue on here. And it looks like step 3, I'm going to go back to router 2 here. So we'll set the router IDs. So actually we have to do EIGRP, router ID, and for router 2 it's just simply 2.2.2.2. For router 1, I'm simply going to say EIGRP, router ID, 1.1.1.1. And now let's step over to router 3, where we're going to say IPv6 router EIGRP1, and then we're going to go ahead and put our, and I keep wanting to go back to the OSPF days, EIGRP router ID, and this is going to be 3.3.3.3. And a quick note on the router ID with distance vector protocols, and specifically with the EIGRP, doesn't play as significant a role as it did with OSPF, because if you remember with OSPF, right, we're actually kind of routing to the node, and this is how the node, every node is identified in the type 1 LSAs in the link state database is by the router ID. And so in OSPF, remember, all of the routers in an area, in the same area, learn basically everything about every other router with respect to the OSPF domain. Whereas with EIGRP, it's distance vector. So EIGRP, he's concerned about his neighbor, and that's about it. He really doesn't care what's going on behind the neighbor. He just knows that, hey, to get to network A, I shove all my traffic over to router 3. And so that's the difference. Whereas with OSPF, remember that each router maintains an identical copy of that link state database within the area, and it's able to identify all of the nodes in that area, and it's based off the router ID. And again, with EIGRP, not as significant a role. However, always a best practice, always a good idea to set the router ID. And so we're going to set it to 3.3.3.3 as it's asking for there. And it says examine the adjacencies. So what we didn't do on router 1 is, if I were to say do show run, and we'll come down here as I see no adjacencies forming, you can see we're still shut down. So we'll say no shut, and if our addressing is set, and it looks like it is do show IP interface brief. I'm sorry, do show IPv6 interface brief. Yeah, so we have our addresses on there. So let's come over to router 3, and we're going to say no shutdown. And so we've got that done. And it wants us to take a look at the using AS1 configure EIGRP. Okay, so AS1 on each of the interfaces here. So let's take a look at the interfaces we have configured. So we'll say do show IPv6 interface brief. And it looks like we're using the gigabit interfaces, but that is not where we would want to unless they're going to have us do a passive interface. And they are not, but we are going to want those networks advertised. So here's what we're going to do. Let's just go ahead and we're going to go into each of the interfaces in turn. So we'll go to interface gigabit 00, and I'm simply going to say IPv6, because remember, the difference between IP or EIGRP with IPv4 as opposed to IPv6 is with EIGRP for IPv6, you can only start the EIGRP process on the interface, at the interface level. With IPv4, we could get away with the network command under the EIGRP router global config section. However, with IPv6, we need to come into the interface, and we're going to say IPv6 EIGRP, and it's very straightforward, 1. So that's going to start the EIGRP process on the gig 00 interface. And then I'm going to go into serial 000. We're going to do the same thing. IPv6 EIGRP 1, and then int serial 001 IPv6 EIGRP 1. All right, and so that should take care of, let's do a quick write mem here on router 3. And let's transition over to router 1, who looks like he's using the same interfaces. So interface gig 00, and we're going to say IPv6 EIGRP, 1, and interface serial 000, and if I have to passive the interfaces, I will, but I don't think it's asking for that on this exercise. IPv6 EIGRP 1, and then interface serial 001 IPv6 EIGRP 1. All right, and so as soon as we did the link between router 3 and router 1, we've got a neighbor that's come up. We have an adjacency. So if I were to say do show IPv6 EIGRP neighbors, you can see there is one of our neighbors right there. And it's the first neighbor learned. This is the interface out which, the local interface out which this adjacency was learned. You can see the hold time is 13 seconds, and that's kind of that timer again that kind of counts down to 10, but then back to 15, right? So every 5 seconds, we should be receiving those messages. And then we have the smooth round trip time, right? And the RTO, and the queue count is 0, and it looks like we're, or stretch it out a little bit. There we go. All right, so we have our adjacency set up between 1 and 3. Now let's jump on to router 2, and we'll say int gig 00 and IPv6 EIGRP 1, interface serial 000, IPv6 EIGRP 1, and then as soon as we did that, our adjacency with router 1 came up, and then interface serial 001 IPv6 EIGRP 1, and what we should see here is the adjacency between router 2 and router 3. All right, so let's end and let's do a quick write mem here to save our configuration information in case anything were to go terribly wrong. And let's do the same thing here. It's going to ask us to do some confirmation here. So it wants to see the show IPv6 route. So we'll say show IPv6 route. And as you can see, we are learning some different prefixes, some different IPv6 addresses, and this is router 1 that we're on, so this is via. So here is my successor, and you can easily tell here this is router 2, and this one is coming from router 3, and so the Cafe 3. So this is the LAN segment behind router 3, and we're learning about the LAN segment behind router 2 as well. And let's test our connectivity here. So I'm going to pull up the PC, and let's go, oops, didn't want to go to config, want to go to desktop, and we'll pull the command prompt up, and let me see if I can ping PC3. So I'm going to say ping 2001:DB8: cafe:3:3, and we can ping over to PC3, and now let's give PC2 a try. looks like our request, the first request, is going to time out. So we may still have a little work to do here with PC2. Did I get that right? Oh, 2.3. I apologize. Let me Control-C. I did not go back far enough on the address. So it's 2:3. ::. There we go. And we've got connectivity over to PC2. Okay. Anything else it wants us to take a look at? We'll take a look at the neighbors here. Let's do it from router 1's perspective. So show IPv6 neighbors. So we want to make sure we take a look at the neighbor table to see the different information that we're learning about our neighbors. So IPv6, show IPv6 EIGRP neighbors, right? And so we have the H column, right? Remembering this is the order, right? The list of the neighbors in the order in which they were learned. Now, remember we said the other day that this is the first neighbor that was learned, and we also saw where these numbers over here, the 1 and the 0, will sometimes be reversed, right? So the link local addresses, okay, this is the neighbors, not our local address. This is the neighbor's link local address right here. So that would be the address for router 3, the link local address, and here's the link local address for router 2. Now, since these are not the local address, these are the local interfaces on which we're receiving those EIGRP hello packets. Every 5 seconds, they're maintaining the adjacency between the routers, and these are the local interfaces on router 1 on which I'm receiving those hellos. The next column we have here is the uptime, or I'm sorry, the hold seconds we talked about. It's same as the dead timer for OSPF, and every 5 seconds it refreshes, and the hold timer starts out at, or I should say the dead timer is 15 seconds. So it starts at 15 and then counts its way down, and we should never see it get below 10. And if you do, that is an indication that your adjacency is going to wither on the vine and die off. So it always goes to 10 and comes back up. Then we have our uptime, and this is just simply the amount of time, I should say, since the neighbor was added. So this is basically how long has this adjacency been established. And so in our case, we got about 4 minutes and 50 seconds and 3 minutes and 50 seconds. And then you've got the SRTT and the RTO, right? The smooth round trip time and the RTO time. And these are used by the Reliable Transport Protocol, RTP, and it's basically used to manage those packets. And then you've got the queue count. The queue count should always be 0, right? Because you should not have updates queuing up. It should always be 0. And then our sequence number, this just tracks the updates, any queries we might get. Pretty sure reply packets, you're going to see those get counted up as well. And so let's take a look at the show IPv6 protocols command. And this is a great command, right? Because it's going to show me my K values. So if you were to be asked, why is the adjacency not establishing, and you were shown the show IPv6 protocols output from 2 routers, if you were to see that the K values did not match, then you would know that it's because the K values are inconsistent, because these need to be the same, right? So the metric weights need to be the same. In fact, let's give it a try here with PacketTracer. If I were to say config T and then IPv6 router EIGRP1, and I think, can we tweak the metric weights here? I hope so. All right, so we'll just say 0, 1, 1, 1, 1, 1. So I'm going to go ahead and change, whoops, let me go ahead and change these. And now, look at that, it went down rather quick. So do show IPv6 neighbor and IPv6 EIGRP neighbor, and it's going too quick. EIGRP, did I get there in time? I don't think I got there in time. So, but again, you can see if the K values don't match, then the adjacency is, one, it won't establish if it hasn't established already, and if it is established, it's going to tear that adjacency down, as we're actually witnessing right now. So I'm actually going to finish up here. I'll just jump over to router 2 and actually it's going to be doing this on all of them. All right, so the show IPv6 protocols command is a great command to take a look at the K values and to see, do I have any mismatches? Okay, so that was a very straightforward exercise. A couple of the key points to remember. Remember that the EIGRP process could be shut down by default. With 15 code, it should not, but I would always check, especially if you've configured both sides and the adjacency doesn't form. That should be the first thing that you check. Check number one, is the EIGRP process for IPv6 shut down? If they're not shut down on either side, the second thing I would check, what about my autonomous system numbers? Do those match? If those match, the next thing I would check is I would check, and hopefully you're going to see these error messages here that you're getting, and let's see if we see those on, we'll come over here to this actual Cisco 1841 router, and what was it, show run section EIGRP. I think I had the same thing here. Yeah, so just IPv6 router EIGRP, and we were using 1, and I'm going to tweak the metric weights here, and we're going to say 1, 2, 3, 4, 5, 6. All right, so let's see how quickly, if I do show IPv6 EIGRP neighbors, and we don't have any neighbors right now. Let me make sure that is, even though there's nothing shut down there. Let's come over here. Actually, that's 12 code. Let me see on this guy here if he's got show IPv6 EIGRP neighbors. All right, so he does have a neighbor, and it is router 5. So let's tweak this guy's packets here, or his K values. So IPv6 router EIGRP, and it should be 1, and we're going to say metric weights 2, 3, 4, 5, 6, and we'll do that, but then we'll quickly, and that was pretty fast right there, so you can see we get the change do show IPv6 EIGRP neighbors, and it went down before I could even get to it. So again, if the K values are mismatched, then that is going to cause some issues, and you can see it's very nice, right? You're getting a great error message here telling you K value mismatch. So that should be your first clue. So if I were to say do show run section EIGRP, I'm going to see this metric weights command here. So what I would say is no, and I should have logging synchronous on here, getting overrun, and do show run section EIGRP. And so it's gone, and there it was. As soon as I took them off, you can see that the adjacency's been reestablished. So do show IPv6 EIGRP neighbors, and my neighbor relationship has been restored. So over here, the reason this didn't come back up is my suspicion. Do show IP interface. I'm trying to remember which interface I configured. So it should have been do show run int fa00. When I did the no IP, yeah, and that's exactly what happened. When I did the command no IPv6 router EIGRP1 to pull the config off to demonstrate for you that the process, the EIGRP process for IPv6 was not shut down by default on the 15.3 code, what happened is you see here, and if we take a look at 01, you're going to see the same thing. Yep. So when I did the no IPv6 router EIGRP1, it literally pulled the configuration off of the interface level as well. So let me put that back in here, interface FA00, and remember we're going to go ahead and say IPv6 EIGRP1 and interface FA01 IPv6 EIGRP1, and there you go. You see how it's coming back up? And it's going to say K value mismatch because we still have that in there. But yep, and there it goes. It came back up on both Fast Ethernet 1 and 00. And so if I do a do show run interface FA00, you see how the command is now in here, right? And I'm going to sort out the IPv6 router EIGRP 1, and we're going to say do show run section EIGRP. Whoops. And let's take a look. We're going to say no, and I'm going to pull the metrics out of here, the K values that are keeping the adjacencies from forming. So as soon as I hit that, within the next couple of seconds, there you go. So the router 4 adjacency came up and the router 3 adjacency came up. And so let's go ahead and see what we're talking about in action here. So if I said do show run int FA00, you can see we've got our IPv6 EIGRP config in here, and then the same thing on on interface FA01. So if I were to say no IPv6 router EIGRP1, the adjacency is going to go down with 3 and 4, but what we're interested in is what does interface FA00 look like and what does 01 look like. And so that's what happened earlier, was that it just simply pulled off the command to enable the EIGRP process on this interface when I removed it. So definitely something to keep in the back of your mind. If you pull your process off and then you assume that the interface config for the EIGRP IPv6 command is going to be there, it might not, right? If the adjacency doesn't come up, this is, again, something else to check. So a couple things we have to check there. And that wraps up our PacketTracer tutorial for PacketTracer Activity 7.4.3.4, configuring basic EIGRP for IPv6. All right, I will see you on Saturday and have a great week.